Hi friends, welcome to GMK tutorials. ఇప్పటివరకు ఇంకా ఎవరైనా మన ఛానల్ సబ్స్క్రైబ్ చేసుకోకుండా ఉంటే సో ప్లీజ్ సబ్స్క్రైబ్ అవర్ ఛానల్ అండ్ ప్లీజ్ వాచ్ ది వీడియో till the end. Okay, your support is also very important for me. Okay, to give more and more videos in image processing and other subjects also, relevant subjects. Okay, so let's move on to the topic. So today topic is the basic relationship between the pixels. It is one of the most important topic in the image processing. Basic relationship between the pixels. So let us consider f of x comma is a image. Already we know that it is f of x comma is a image that consisting of the x comma y are generally spatial coordinates. X comma y are generally spatial coordinates of the image. Then so in this relation point of view, just we will take these two pixels. That pixels can be represented as a p and q are the names given to the pixels in case of the examples point of view. So let us consider p and q are the two pixels. Okay, so first of all we have to define what is meant by neighboring pixels or neighbors of pixels. So suppose if you want to say that if a pixel p and q are two pixels, if a q is a neighbor of p, how can you define that relation? That is one of the most important. So for that purpose, let us see here neighbors of pixel. A pixel p at coordinates x comma y. Suppose if you are considering the p is a pixel, that pixel having a coordinates of x comma y has a 4 horizontal and vertical neighbors whose coordinates are given by x plus 1, x minus 1, comma y, x comma y plus 1 and x comma y minus. These are the four neighbors of the corresponding pixel x comma y. This set of pixels are called four neighbors of p is denoted by n4 of p. So n4 of means that 4 means that 4 neighbors of p. 4 neighbors of p. So these are the neighboring pixels of the x comma y. Suppose if you, let us consider here, just I will take this is a location. This is a x comma y location. So there is a one pixel is there, this is also there, this is also there, these are the locations. So x minus 1 means that before row can be represented as x minus 1, same column, therefore x minus 1 comma y. So this is nothing but same row, but column is included, x comma y plus 1, this row. Okay, so this is nothing but same row, x comma, column is decremented, therefore y minus 1. So row is incremented, x plus 1 comma same column. So that's why these are the coordinates. So this can be represented from this line actually. So these are can be represented from here. So x comma y is a central pixel. This is nothing but x minus 1 comma y. So x minus 1 comma y, this one, x minus 1. So here row is incremented, therefore x plus 1 comma y, x plus 1 comma y. This is another pixel. This is also x comma y minus 1. So same row, one column is before this one, therefore x comma y minus 1. This is nothing but same row, but column is incremented, x comma y plus 1. This is nothing but x comma y plus 1, therefore x comma y. These are the four neighbors of the corresponding pixel. Moreover, in the image processing, the distance between the two pixels is only unit distance. That means the corresponding distance between the two pixels is the only unit distance. Some of the neighbors of p, locations of p, is lie outside of the digital image. In case if it is a border, suppose these pixels also there is a possibility if the p pixel is the border of the pixel, at that time there is a possibility of some missing neighbors will be existing in such a cases also. That is the main thing. Suppose the four diagonals of neighbors of p has a coordinates is nothing but like this. Suppose diagonal elements means that previously observed that suppose this is nothing but x comma y location. So this is a neighbors. Okay, these are the neighboring pixels, but there is a possibility of another pixel that is nothing but diagonal pixel. This pixel is a diagonal, this is also diagonal, this pixel is also diagonal, this is also diagonal. So these diagonal pixels can be represented as the coordinates of this one. These are the diagonal pixels coordinates. Okay, diagonal pixels of the corresponding diagonal pixel. So how can I represent this one? This pixel is a diagonal, right? So this is a row before this one, therefore x minus this location is generally called as x before row x minus 1, but column is increment x minus 1 comma y plus 1. Y plus 1. Okay, x minus 1 comma y plus x minus 1 comma y plus 1. So this is also this is also same column, same row, but column is decrement. Therefore x minus 1, this location x minus 1 comma y minus 1. X minus 1 comma y minus 1, x minus 1 comma y minus 1. This is also row incremented. Therefore x plus 1, but column is also incremented in this direction. Therefore x plus 1 comma y plus 1. X plus 1 comma y plus 1. This is also row is but here row is incremented, but column is decremented. So x plus 1 comma y minus 1, x plus 1 comma y. So these are the 4 diagonals of the corresponding pixel. This is a represent. Here also same thing. In case the corresponding pixel may be diagonal pixel may be, if the p is lie outside of the corresponding image, there is a possibility of some neighbors or diagonal pixels also missing at that time. So, up to now we have some clarity will be there. So, what is meant by 4 neighbors of pixel P and what are the 4 diagonals of the pixel? If the 4 diagonal pixels and 4 neighbors of P can be treated as the 8 neighbors of P. So, that is nothing but 8 neighbors of P. Okay. So, that is nothing but these points together, diagonal points together with the 4 neighbors are called as 8 neighbors of P that can be represented as n8 of P. So generally 4 neighbors can be represented as n4 of P. This is nothing but 4 neighbors pointer. At the same time diagonal point nd of P, 4 diagonals of P. At the same time 8 neighbors of P can be n8 of P. That means 8 neighbors of P. So that is the representation of the how we are going to define the 4 neighbors of P and the diagonal elements as well as the 8 neighbors of P. So let us see, we will consider the adjacency point of view. Let us consider, let V be the set of the intensity values used to define a adjacency. Suppose if you want to define the adjacency of any 2 pixels, we will consider some set of intensity values. Suppose if you are consisting the image, that image consisting of a more value, that means up to 0 to 255 intensity values is it. In the some of the images may not be consisting all values. So some of the particular points may be existing. That particular points can be treated as some set actually. So like that we will consider in case of the binary image, V is equal to 1, that is a set. It will be referring to the adjacency of the pixel with the value of 1 point of view. Okay. So in a grayscale image, we know that the set V contains more elements, that is nothing but 0 to 255. So that so at that time V could be a subset of these 256. So yes or no? So in case of a grayscale image, 0 to 255 are the most maximum values of grayscale image. But in some application, the corresponding grayscale image may not be consisting all the values. It may be consisting some of the values. That some of the values are generally called as a subset of the corresponding 256 values. Okay. Now just we have to define what is meant by 4 adjacency. Okay. What is meant by 4 adjacency? So 4 adjacency means that 2 pixels P and Q with values from V are 4 adjacent if Q is in the set of 4 neighbors of Q. So that means if P Q అనేది గాని P కి adjacent గా ఉంది అని చెప్పాలంటే కంపల్సరీ this Q is in the 4 neighbors of P కి present. That means if you are treating this one, let us consider here. This is the central pixel value. These are the neighboring. This is the one location. This is one location. This is generally called as the 4 neighbors of P. This is a P location. This is a P location. Suppose if this Q is said to be, suppose the Q is said to be, this Q is said to be adjacent to the P means that the Q may exist in this place or maybe this place or maybe this place or maybe this. That means any 4 sides, any of the 4 places there is a possibility for P is locating, then only we can say that the corresponding Q is a 4 adjacency to the corresponding pixel P. That is the basic. I hope అర్థమైంది అనుకున్నా. సో ఇక్కడ Q అనేది గాని P P అనే పిక్సెల్ కి అడ్జసెంట్ ఉండాలి అంటే ఈ Q అనేది కంపల్సరీ 4 నైబర్స్ ఆఫ్ P లో ఏదో ఒక లొకేషన్ లో ప్రెసెంట్ అయి ఉండాలి. దెన్ ఓన్లీ వీ కెన్ సే దట్ Q is the 4 adjacent of the P అని చెప్తాం. ఓకేనా? దెన్ 8 adjacency means that here 8 adjacency means that 2 pixels P and Q from the set V. If adjacent of Q is nothing but the Q is present in the 8 neighbors of P. Suppose 4 adjacency means that the Q is present in 4 neighbors of P. Or else if you want to say that Q is 8 adjacent of P, at the time compulsory the Q may be existing 4 neighbors or maybe 4 diagonals of P also. Okay, out of these 8 locations, any one of the location the Q may be present, then we can say that Q is the 8 adjacent of the corresponding Q. Then coming to the M adjacency means that it is generally called the mixed adjacency. Okay, it is a mixed adjacency. So 2 pixels P and Q with values from set V or M adjacent means that we can say that when the Q is in the 4 neighbors of P and Ali, or else Q is in the 4 diagonals of P. So the Q may be present in the 4 neighbors of P if at the same time Q is in the 4 diagonals of P. At the same time 4 diagonals of P and 4 diagonals Q the intersection of those two values must be 0. That means no common pixels existing between the 4 neighbors of P and 4 neighbors of Q. This is generally called as a mixed adjacent. Mixed means that it consisting of both diagonal elements as well as a neighboring. So that's why we can call it a mixed adjacency. Okay, this is nothing but just a relation between pixels. Then how can I represent the distance measure? Suppose if we want to find out the distance between the 2 pixels, how we are going to defining that one? So this is also one of the most important topic. Let's move on to this one. Distance measure for a pixels P and Q. So in this point also just we will take 3 pixels for the example point, that is nothing but P and Q and Z with coordinates. P comma Q with coordinates is nothing but X comma Y, S comma T, V comma W. These are the corresponding respective coordinates. That means P is consisting of a coordinates of X comma Y. At the same time Q is having a coordinates of S comma T. At the same time Z is having a coordinates of V comma W. Okay, then D is a distance metric. D is a distance metric. So these are the some of the rules you have to follow. D of P comma Q, that means the distance of P comma Q is greater than 0. The distance between the P and Q is greater than 0 when D of P comma Q is equal to 0 if P and Q both are same. That means if the P pixel and Q pixel are same, means that obviously we don't have any distance, right? So that's why if the D of P comma Q value is equal to 0 when both pixels are the same. If the D of P comma Q or pixels are maybe 2 different pixels, at that time the distance is compulsory greater than 0. Second thing is nothing but the distance between P comma Q is also equal to distance of Q comma K. Obviously maki distance from P nunchi Q ki anta distance undo, Q nunchi P ki kuda same distance unda, so that is also same thing. At the same time the distance of P comma Z is less than or equal to distance of P comma Q plus distance of Q comma Z. Suppose let us consider, just I will write down just over here, this is the one location, this is also one location. I will consider just I will represent another color from this one. Okay, so I will treat it as a Z P Q. So what I am saying here is the distance between, suppose the distance between this XZ is obviously less than from the distance from P to Q and P plus Q. అంటే Z నుంచి X కున్న distance obviously is less than P నుంచి Q కి వెళ్ళేసి Q నుంచి మళ్ళీ Z కున్న distance తో కంపేర్ చేస్తే the distance between the two is also very less. So that is the basic thing here. Then the Euclidean distance between P and Q is defined as, that means if you basically the distance, if you want to find out the distance between 2 pixels, obviously we are using a Euclidean distance is the one of the measurement. Okay, for that purpose, let us see what is meant by Euclidean distance. So here Euclidean distance is defined as D means that here E represents the Euclidean distance. D is nothing but distance point of. Okay, the Euclidean distance between P comma Q is represented x minus s whole square plus y minus t whole square into whole power 1 by 2. We can also define a square root of x minus s whole square plus y minus t whole square. For distance measure, the pixels having a distance less than or equal to some value r from x comma y. These points in a continuous of a radius of L. Suppose that means if you are writing like this, the radius of the remaining pixels also consisting of the same circle. That is the basic thing. As well as the distance D4, it is also called as a city block distance. The distance D4 is also called as a city block distance. It can be represented as D4 of P comma Q is equal to modulus of x minus s plus y minus t. So that means here the distance between the first pixels and the distance of the second pixel calculate chesare, then we can take the modulus of that. Add chesin tarvata whatever the value we are getting maximum, that value can be treated as a D4 distance. In this case also same thing, if it is less than or equal to some value r from the diamond center, the pixels is, suppose this is the scenario. So diamond shape to consider chesarande, so the central pixels obviously distance is decreases order. Okay. Suppose if the D4 distance is equal to 1, it is equal to 4 neighbors of P. Suppose the distance is less than or equal to, suppose the distance value is equal to 1 means, so obviously what happens is that these neighbors are not present. Okay, this is not present means that obviously what happens, this is equal to only 4 neighbors. So the distance is equal to, so this is nothing but 4 neighbors of P also. Okay. Then the pixel that is represented in this one also. Then D8 distance means previous D8 distance is also called as a chessboard distance between the P comma Q is defined as D8 of P comma Q is equal to, so previous ga as chess తీసుకున్నాం, then ఇక్కడ ఏంటంటే maximum of those two, అంటే difference of x minus s comma y minus t లో ఏదైతే maximum value ఉందో that maximum value can be treated as a D8 of P comma Q. So that is the basic thing. So ఈ example just we will take square of a distance of 2 ga consider chesam. Here also same thing, if the distance is equal to 1 అయితే then it is also called as 8 neighbors of. That means 8 neighbors means that obviously the border pixels may not be present. This is equal to central pixel, this is equal to central pixel, these are the diagonal pixels, these are all the diagonal values. Okay, these are called as a neighbors, neighboring pixels, diagonal pixel, neighbor, diagonal, neighbor, diagonal, neighbor, diagonal. So this is generally equal to 8 neighbors point of view. So note that D4 and D8 distance between P and Q is independent of any path that might be existing between, because these distances involve only coordinates of the point. That means D4 and D8 distances independent of the path. So we don't want to consider about the corresponding path, just it will consider the only corresponding coordinates of the points only. Okay. If you want to elect the M adjacency, the DM distance between the 2 points, the D8 is nothing but, if you want to select the D8 distance, it is called as a chessboard distance. So it is also called as chessboard distance. We can also treat it as 8 neighbors of P. Then we can define the M adjacency. So M adjacency means that here M adjacency means that M adjacency is considered as DM. It is nothing but distance between the P comma Q is 2 points is defined as the shortest M path between the points. DM is nothing but M adjacency is also called as it is the shortest between the 2 points is generally used in case of the M adjacency. So in this case, the distance between the pixels will depends on the values of the pixels along the path as well as along the neighbors. So previously, in case of the D4 and D8 ranges, under the distance between two pixels is nothing but is purely independent of the corresponding path. It is directly depends on the coordinate. But in case of the DM distance, it is also depends on the corresponding values as well as along the paths of the corresponding pixels. So let us consider, for example point, we will take it as an example here. So this is a scenario. Okay, so consider the following example, it gives some idea. So here we will take 4 pixels, that is nothing but P1, P1, P2, P1, P2, P and P3, P4. For example point, we will take 4 values, right? So here consider the adjacency of the pixel value 1. If the P1 to P3 are 0, the length of the shortest path M path between the pixels is nothing but, suppose if the P1, P3 are 0, this value is 0, this value is 0 means that obviously the shortest between the P1 and the distance between P1 and P4 is only 2. This is 1 unit, this is 1 unit, this is a 1 unit. So distance between 2 units only 2 units, right? Suppose if you are taking the another consideration, okay, let us see here, just if the pixels having a distance of, so ఇక్కడ ఏం చేస్తాం మనం P1 P3 అనేది 0 కి assumption తీసుకుంటే distance P1 to P4 వచ్చేసి మనకి ఓన్లీ 2 యూనిట్స్ ప్రెజెంట్ అయింది. సపోజ్ అనదర్ సినారియోలో ఉంటుంది, ఇఫ్ ఇన్ కేస్ P1 P4 కానీ P1 P3 కానీ సమ్ వాల్యూస్ ఏదైనా ఉన్నాయని అజంప్షన్ తీసుకుంటే, సో సెకండ్ కన్సిడరేషన్ ఈస్ నథింగ్ బట్ ఏం అజంప్షన్ తీసుకుందాం అంటే, సిమిలర్లీ if the P1 is 1 and P2 and if P1 is 1, suppose same scenario, just P1, P2, P3, P4, right? So this is the answer. In this case, what happens is that if P1 is 1, P2 and if P1 is 1, at that time what is the scenario? P1 1 అయిందంటే, so P1 1 ఉందంటే compulsory you have to consider this path also. So this is also location 2, 3, 4. So this distance is also equal to 4. So the shortest between, moreover, if you are treating this as a 4 consideration, if your P1 and P3 is equal 1 అయితే 4. Suppose another consideration is nothing but, if this P1 value is equal 0, if I will treat P3 is equal 0, at that time what is the shortest? 1, 2 and this diagonal. So 1 unit, 2, 3. So this is nothing but shortest path means P2 P1 and P1 to P2 and P2 to directly P4. So the distance is in this case is equal 3. That means in case of the M adjacency, not only we will consider the path direction, we will also consider the values. Based on the corresponding values, we have to decide the corresponding path. Okay, so that is nothing but M adjacency. Okay, I hope this video is very clear for you, I think, up to now. Next one is nothing but mathematical tools used in the image processing. Okay, that will be discussed in the next video. Thank you for watching GMK Tutorials. Thank you.